So hello, in the previous class we talked about how to create a lexical analyzer by hand. So as you will remember, lexical analyzer is a part of the compiler which takes as an input a statement or a program, an expression like here 15 plus 30 into 20 minus 11, and it generates from this statement or program, it generates a stream of tokens. In this particular case, for 15 it generates the token number, for this plus it generates this plus, for this 30 it generates number, for a star it generates mul, etc., and finally it generates this entire stream of tokens. Therefore, the input to a lexical analyzer is a statement or a program, and the output is a stream of tokens. Tokens are small integers that represents various parts of speech. In C programming, we typically use an enumerated data type to represent each token. Say for example, if we store information about the tokens in a string array, the indices of this array might represent the token, and the contents of this array might represent the string representation of that token. For example, here we are saying that index 0 or token 0 actually has the string representation plus. Token 1 has the string representation minus. Token 2 has the string representation mul, etc. Once we have this token representation using an enumerated data type, now it's the turn to actually go ahead and draw a transition diagram of a finite state automata which accepts the various tokens for our language. For example, we could start with this initial state, and remember how initial states are marked. Whenever we have a state where there is a single arrow entering, that is the initial state. So here in this particular transition diagram, 0 is the initial state, and all these states where there are two circles, concentric circles, they are final states. So for example, this is the final state. Now whenever we are in the initial state of this DFA and the plus token arrives as an input, then we reach this final state where we will return the plus token. Similarly, if we happen to get a semicolon here in the initial state 0, we get this semicolon. Now we will reach or transition into this state 4 where we will return the semicolon token. For a number, it becomes slightly tricky because it does not enter whenever we get a digit. We directly don't enter a final state, but instead we enter this intermediate state phi where we continue to accept digits until we find that some other character other than a digit has been input, in which case we enter this final state and return the token number. Now once this DFA transition diagram is ready, now it's a simple mechanical technique to convert this DFA into a C program. As you would remember, this C program, in order to represent a DFA, must have an outermost while loop, and inside this is step number 1, and inside this while loop we will have to write a switch state statement, switch state, and while we write inside the switch statement, which is step number 2, we write different cases, and each of the cases represent a state. For example, the DF on the left has 7 states starting from 0 to 6. Therefore, there will, for this switch state case, there will be 7 cases: case 0, case 1, case 2 until case 6. As the third and the last step, for each case we will continue to write another switch, but this time we are going to switch on character. So we have already seen how such an implementation, mechanical implementation, lets us take a transition diagram or a DFA and convert into C program. This C program is the source code for our lexical analyzer. This approach that we have talked about in the previous class gives us what is called a handwritten lexical analyzer. But in today's class, we are not going to discuss handwritten lexical analyzer. Instead, we are interested in a far easier solution, and that solution will be, in the second case, in order to write a lexical analyzer, we are going to use a lexical analyzer generator. So this lexical analyzer generator, in Linux, this lexical analyzer generator is named as flex, stands for fast lex. Now, in order to use this lexical analyzer generator, you have to install it in your system. So in order to install this flex software, we have to type the command sudo apt install flex -y. So after the installation of this flex in our system, we have to input into this flex description of tokens in English-like language. See how simple this is. The lexical analyzer generator takes as an input the description of tokens, and then what will be the output of this lexical analyzer generator? This will be a DFA, a deterministic finite automata in C language. This DFA in C language is actually this C program, which is precisely our lexical analyzer. You have to compile this C program and we will get the corresponding lexical analyzer executable.